Have you ever wanted to make something, well, move? A robot, an art project, you name it. If so, you are in exactly the right place. Today we're going to build the one circuit that is the key to all of it. So let's get this mission started.
I mean, seriously, who hasn't, right? The dream of telling a machine to go, stop, turn around, that's the heart of robotics. And you know what? It's a lot closer than you probably think.
And it all begins right here. This single circuit is the foundation. It's the building block you absolutely need to nail down before you can build literally any project that moves.
All right, Section 1. Let's talk about our mission. The objective is clear, and it's simple. We're going to take total control of a motor.
Okay, Section 2. Meet the team. You can't pull off a mission without a good crew, right? So let's get to know our components and what each one of them does. First up, the star of the show, the Arduino. This is our brain. It's the thinker, the decision maker. It sends out these little low-power signals, basically just whispers saying go or stop.
Next, we've got the L298N motor driver. Now, if the Arduino is the brain, think of this as the muscle controller. It listens to the brain's quiet signals and then turns them into these big, powerful commands that can do some real work.
And here is the muscle itself, our DC motor. This thing doesn't think, it just does. When that muscle controller gives it the juice, it does the one thing it's great at. It spins, giving us that real-world movement.
And last but not least, the power source. See, the brain can power itself over USB, but our muscle, it needs a lot more energy. This battery pack is like a power lunch just for the motor, giving it all the raw energy it needs to get the job done.
Section 3. Preparation. Okay, before we touch a single wire, we gotta talk safety and take a look at our blueprint. First things first.
These 4 rules, they are absolutely non-negotiable. 1. Work on something like wood or plastic, never metal. 2. Once things get powered up, keep your fingers away from that spinning motor shaft. 3. Red is positive, black is negative, always double check. And 4. The most important rule of them all, we connect the main battery power at the very, very end, not a second sooner.
And here it is. This is our blueprint, our map to success. This circuit diagram shows us exactly how every single member of our team connects to all the others. We're going to follow this thing to the letter.
Section 4. Assembly. All right, it is time to start wiring this thing up. And let me say it again, no batteries yet.
First up, let's connect the muscle to its controller. Just take the 2 wires coming off your motor and screw them into the terminals labeled Out 1 and Out 2 on the driver. And here's a cool little tip. For now, it actually doesn't matter which wire goes where. If it spins the wrong way later, we'll just swap them. Easy.
Next, let's hook the controller up to the brain. This is how the brain is going to issue its commands. So the pin marked ENA goes to pin 3 on the Arduino. See that little squiggly line next to the 3? That means it can control speed, which is pretty cool. Then IN1 goes to pin 8, and IN2 goes to pin 9. Those 2 are going to tell it which direction to spin.
Okay, stop. Pause for a second. We've connected the muscle to the controller and the controller to the brain. But for them to actually understand each other, we need one more wire. And I am not kidding when I say this might be the single most important connection in this whole project.
It's the common ground. It's just one little wire going from a pin marked GND, for ground, on the driver to any pin marked GND on the Arduino. So why is this so important? Well, without this shared connection, it's like the brain and the controller are speaking 2 different languages. The signals just become noise. Forgetting this one wire is hands down the #1 reason these circuits don't work.
Section 5. The instructions. Okay, the physical build is done. Now it's time to actually program the brain and give it some instructions.
Inside our code, these 2 lines do all the magic. We're basically telling the Arduino, hey, turn pin IN1 on, or high, and turn pin IN2 off, or low. So what does that actually mean for our motor? Well, it's pretty simple. It's the command for spin forward. By setting one pin high and the other low, we're telling that motor driver exactly which way to send the power. And check out how elegant this is. To go forward, IN1 is high and IN2 is low. Want to go backward? You just flip them. Now IN1 is low and IN2 is high. It's just like flipping a digital switch. So simple, so cool. So, what about speed? Remember that ENA pin we connected? We control speed by sending it a number, anywhere from 0, which is stop, to 255.
So, sending it 255 like you see here, that's the command for full speed ahead. If we wanted about half speed, we just send it something like 128. It's like a volume knob for power. Section 6. Mission Go Live. Okay, deep breaths everyone. The wiring is solid, the code is ready to go, it is time for the final test.
Let's follow this final sequence exactly. Step 1. Plug the Arduino into your computer with the USB cable and upload the code. Step 2. And this is important, once the code is uploaded, unplug the USB cable. And step 3. Only now do you connect the battery pack to the motor driver. If everything went to plan, your motor should be spinning right now.
But what if it's not? What if it's just sitting there? First off, don't panic. This is all part of the process. This is what engineering is all about. So let's just run a quick diagnostic check. Here are the top 3 culprits. Number 1, are your batteries fresh? A weak power supply is a super common problem. Number 2, and I'm going to say it one more time, did you connect that common ground wire? Go, check it right now. And number 3, just take a second and trace your 3 little control wires, ENA, IN1, and IN2, and make sure they landed on the right Arduino pins. So, whether it worked right away or you had to do a little troubleshooting, congratulations, you did it. This isn't just a spinning motor. You've built a whole system, a brain, a controller, a muscle, a power source, all working together. You now know the fundamental secret to making things move. You've totally mastered one motor. That is a massive first step, which really just leaves us with one last, very exciting question. One motor can spin in a circle, but what kind of amazing things could you build if you had 2?